postdoctoral research experience at Microelectronics and Electrical Engineering Department of Trinity College, Dublin, Ireland. Dr. is a reputed DRDO scientist with 3 decades of experience in the field of missile technology at Research Center Emirat, or RCI, located at Hyderabad. RCI is the brainchild of Dr. APJ Abdul Kalam and specializes in avionics, navigation systems, control systems, radar systems for Agni, Prithvi, Danish, and air defense AD missiles. Doctor has been awarded Japan Matsumai International Foundation Medal in 1987 and Materials Research Society of India, or MRSI Medal, in 1990. Other notable contributions of the doctor include piezoelectric sonar systems for Indian Navy while working at NMRL Mumbai during 1984 to 1988. Before moving over to RCI Hyderabad, Dr. Varaprasad served DRDO for 28 years and retired from DRDO services in 2012. Presently, Dr. Varaprasad is professor of ECE department at St. Anne's College of Engineering Technology, JNT University, Kakinada, involved in teaching and research on satellite systems. Sir, we request to deliver keynote address to the conference. Let us welcome Dr. Andy Murali Varaprasad. Morning. Good morning, sir. Good morning, doctor. You're on mute. Hi, good morning. Yes.
Okay. Very nice. First, should I start the lecture now?
Go ahead, sir. Please proceed.
Okay. First of all, I am very thankful to Dr. Patil sir for giving me the introduction about me, and yourself also. You have read about the biodata very nicely. So actually, the topic that I have chosen for today's talk is space science and technologies, advances in the space science and technologies. In fact, in colleges, we really don't have many subjects are in the branches. See, in my college, in electronics and communication, there is one satellite communication subject. Apart from that, there is no other. That is also elective. That is also elective. You know, now I will go to the presentation. That will be, may I share my slides?
Go ahead, Professor.
Okay. Am I able to share it? Hello?
Not yet. Not yet.
Not yet. How to share the screen? Okay. How to share it? Share screen.
Yes. When you click on share screen, Professor, you will see there there will be a screen that will pop up. Please make sure to choose the PowerPoint presentation before you click on share.
Okay, this is my PowerPoint presentation. Okay.
There you go.
Yes, yes.
There it is.
Yes. Yeah, we are able to get it. Now, This is the introduction slide about our engineering college, Visanikethan's Engineering College, and then management also they are teaching. Very good, very good. Dr. Patil sir has given very good briefing about the college also. The topic is name I have chosen Advances in Space Science and Technologies. I actually belong to DRDO. After retirement in 2012, I joined this St. Anne's College of Engineering and Technology. Here you see I am the director of Center for ISRO GNSS Studies. This word ISRO GNSS is referring to actually Indian GPS. Indian ISRO GPS. GNSS is actually GPS only. GPS is a word registered by the United States, so we cannot use that word that much. So GPS, Indian GPS. So today you will be able to find a lot of improvement in our Indian scenario by having Indian own GPS. This has started in mobiles last year, but it has not yet become so popular. But I hope in future it will become very much popular. So around 2,000 rupees extra you have to put for the GPS plus NAVIC, we call it NAVIC. That is navigation with the Indian constellation of satellites. I will go through that in the few future slides. I request you to note down one thing. Here my mail ID, amvaraprasad@gmail.com. This mail ID, if you is a connection, whenever you need any information, not only for this conference, but in general also, you can approach me through this mail ID. Have you noted down? Please note down my mail ID, amvaraprasad@gmail.com. This is for our future contact. Now I will go to the first slide. Yes, this is a very interesting slide. You know, on 11th May 1998, we have done that Operation Shakti. And this is Kalam sir in the army uniform. This is chief of our Department of Atomic Energy. His name is Dr. R. Chidambaram. So chief of DRDO and chief of Atomic Energy Commission. Both of them were involved in doing this very highly secretive work, and they have actually done it so much. They got the name of nation has been on the United in the world. Okay, now I want to go first to pay my respects to him and to contribute to this. His name, he wanted to make the India the developed nation in his lifetime. It has still a dream. So I want to read what he has got the message. My message, Dr. Kalam's message, especially to young people, is to have courage. Is to have courage to think differently. Courage to invent, courage to travel the unexplored paths, courage to discover the impossible and to conquer the problems and succeed. Problems will always be there. You have to conquer the problems, the courage, and then succeed. These are the great qualities that they must work towards, the youth of India. This is my message to the young people of India. That's what he said. So remember that, and you also take a pledge. As the youth of my nation, I will work with courage to achieve success in all my missions and to make my India a developed nation. That is what we need. We need to make what his dream is, India to be one of the developed nations, and we should make his dream. That is the way we have to pay his tributes to this great soul. So, before these are some of the slides that I am going to show. So initially I thought I planned for about 1 hour lecture, but now I know that it is 30 minutes. So mostly these 1, 2, 3 introduction of the space science, speed of the satellites and the space temperatures. These are fundamental basic knowledge that you need. Then I will also talk about International Space Station and the small satellite constellations. These are about 4 slides. And ISRO's 104 satellites that has been kept into the orbit on 15th February 2018, and how these are useful for the development of the world. That also we will talk about. Chandrayaan 2 also is one of our most promising, most interesting thing that we have done. Parker satellite, this is an American satellite orbiting the sun at the highest speeds. That also I will do. And this academic tree of Nobel laureates. For the last almost 9 years, I retired in 2012. Since then, I have been in academic circles. So again, my academic connections are also coming to my mind. So I will talk about the Nobel laureates whom I have some association through my professors, through some other contacts. That also I will talk about. But now 15 slides may take about 30 minutes, in my opinion. Then there are something that I want to talk about our rocketry and all. Dr. Kalam Sir's missile complex, if possible, or if it is not possible, this we will be not be able to cover probably. So let me go ahead with the first technical slide. This is the first technical slide that I am showing. This is International Space Station. This International Space Station, from one end to the other end, it is about 1,000 meters. That is the living space. And these are solar panels. 500 meters this side, 500 meters this side. It is also 1 kilometer. So this is the one which is revolving around the globe, our Earth, at a height of 400 kilometers, at a speed of 28,000 kilometers per hour. And we are able to observe and take photographs through one of the things called windows called cupola. So this one refers to the moon where when I was doing my degree, undergraduation, that time he was the 1969, 69, or I just completed inter that time. So, Neil Armstrong was there on the moon, 1969 July, and Buzz Aldrin. Buzz Aldrin is still alive. He is a great inspiration, great motivator for the whole people who are exploring the moon, who want to go to the moon, and in the near future, say 2024 or 25, like that. So we will talk about these things. The space unites the world. The world, it was a World Space Week event title, and I talked to some of the people who are in the space, astronauts, cosmonauts, really Russian cosmonauts. So I will explain to you in the one of the slides. See, basics we have to understand first. When we want to talk about space, we have to first of all understand some of the basics. This slide will tell you about the basics. Here you can see on the y-axis altitude from the Earth's surface, and this pale yellow color, pale blue color is our atmosphere. So around 100, 110, the atmosphere will end up, and then we are going up to 400 kilometers, which is called here, it is the International Space Station. Just I have shown you about 1,000 meters or 1 kilometer length from one end to the other end, the living place, where one of our familiar names is Sunita Williams, Indian origin woman. She was there in this space station 2 times. One term means about 6 months. So one term means about 6 months. So she was there in this International Space Station. Now it is revolving around the globe at 90 minutes one orbit. 90 minutes, only 90 minutes. So then this is about the Hubble Space Telescope. This Hubble Space Telescope is at about 700 kilometers altitude. You know, our missile, Agni missile go up to 700 kilometers altitude. Then travel in the space for about for 5,000 kilometers or 6,000 kilometers, that is designated distance, then re-enter into this atmosphere. See, when it is re-entering into the atmosphere, here is a real problem. What we call plasma will be generated. Because these air molecules here they are very low density also, but they hit like bullets, and in milliseconds time, 100 milliseconds time, the temperatures will raise up to 3,000 degrees centigrade. Anything will be born off. That is the thing problem. So you may remember Kalpana Chawla's tragedy, Columbia tragedy we call Kalpana Chawla, one of the worst things in the history of space science. So Kalpana Chawla, she was there in the space for about 16 days while returning back on February 1st, 2003. So she, the whole group of 7 astronauts, they that Columbia tragedy has happened, and we always pray on that day our remembrances to Kalpana Chawla and all. Now let us look at this. Here, what is the speed of ISS? This is in kilometers per second. 7 to 7.5 kilometers per second is the speed of International Space Station in this region. You see this equation, simple equation, V is equal to square root of Gm by R. What is G? Gravitational constant, and M is the mass of Earth. Mass of Earth. So velocity of any object, irrespective of its weight, there is no weight of the satellite. It is the mass of the Earth, not the satellite. So it is actually a dependent only on the R. What is R? R is the distance of the satellite, height of the satellite, or you call it altitude of the satellite from surface of the Earth to its position. So now this is R is about 400 kilometers. Here you can see here, this is logarithmic scale. So 100, here it is about 400 kilometers. So this is 500, so it will be something like this, 400 kilometers. At that time, this is a wonder. This is a wonder. Actually, all our satellite technologies are because of this fundamental property of gravity. So now if you go further up, that is around something. Lagos satellite is about 19,000 kilometers. No, it is less than that. So Lagos is a reflector satellite, laser reflector. This is used for measuring the precise measurement of the distances and all. So Lagos satellite, there are 2 Lagos satellites. This is a reference satellite. It is very, very important. These are all laser reflectors. The surface of it, you see dots. These are all laser reflectors. So this is for the reference measurements, or for a standard, you can say it is a standard measurement. So techniques, 2 satellites. Then if you, this is at about around I think the distance 5,900 kilometers is the altitude of this, but that is not adjusted by any electronics. That is kept there, and it will be sending laser lights to the surface of the Earth and measuring precise measurements. So Lagos satellites are something which one has to use it as a reference beam. Then you come up to further thing. Here you get GPS satellites, geographical positioning systems. This is also, Lagos is also in middle Earth orbit. This is also middle Earth orbit. So here it is about 20,000 kilometers altitude. At 20,000 kilometers altitude, GPS satellites, American GPS, or it may be Galileo satellites of Russia, Galileo satellites of the European Union, or the GLONASS of the Russian satellites. All these satellites will be operating here in this regime, that is about 20,000 plus minus 100. So now Indian GPS I have talked about. Indian GPS, the satellites of Indian GPS are actually not at this level. We have kept our regional satellites at a height of 36,000 kilometers, that is called geostationary orbit. Geostationary orbit, that is 36,000 kilometers. These satellites, 7 satellites only, out of this, 3 are in the equatorial plane. See, geostationary satellites, same altitude, if you are tilting it, same inclination if you are giving to the orbit, so at about 30 degrees angle inclination, 4 satellites are running. So all these 7 satellites of our, the 4 satellites which are orbiting at an inclination, those are called geosynchronous satellites. So these 7 satellites of Indian GPS are at this height, 36,000 kilometers. And here, this is why it is called geostationary, because this 3 kilometers is the speed of 3 kilometers per second is the speed of these satellites. And Earth is on the surface of the Earth. If you put a receiver antenna radar, so then all these things will be able to focus with the same thing as though stationary. What I mean to say is, it is Earth is here, here is our satellite beam coming, and if this is moving, this is also moving like that. So that is why it is called geostationary. With respect to the thing, receiver on the Earth, it is stationary. So now these are about 36,000 kilometers height. Now if you go to the further up, here is about 1 lakh kilometers, then 4 lakh kilometers, 3,85,000 kilometers. The moon is there. So the moon speed is about 1 kilometer per second, only 1 kilometer per second. See, right now, people are planning to go to the moon, and NASA is making a lot of plans to have a gateway, that is gateway to the moon, or it is like a space station of the moon that will go around the moon. So that is the work. Artemis is the program they are having. So these things are going to happen within a few years time. Now I want to tell something about recent things, that is this Blue Origin. They have gone recently into the space. They have gone up to 110 kilometers height here. See, the difference between a person coming from International Space Station 400 kilometers height to the Earth landing. See, this is very, it will face here a lot of what called re-entry problems, because the speed is very high, 28,000 kilometers, and Earth's gravity and all, it will be there. But astronauts which are returning in the Soyuz capsule or the the recent SpaceX capsule, they face high G. That is, if I am 60 kilograms weight, in addition to my static weight, 60 kilograms, there will be a kinetic weight which will be 3 times that. So that is 180. Total 240 kilograms I will feel for about 6-7 minutes when we are traveling from 100 kilometers up to 35 kilometers. This is really a very big challenge. The astronauts are trained mainly for surviving in this type of high G effects. Whereas our people who have gone Blue Origin, it has gone up to 110. So Blue Origin people, they don't face that, because that is not having that high G effects. It is at a very low speed. So compared to this, and then they will be able to, they don't face that. Only zero gravity they will face, but not the high G effects they don't face. So physically, even if you don't train, only any ordinary citizen who is interested, who can spend, he is able to go into that space. See, one more thing, Bandla Sirisha, there is one more thing, Virgin Galactic. They have gone only up to 86 kilometers height, but that also is space, because there also you will face because almost microgravity conditions. So they are able to fly 3 minutes around that time. So here, if we want to talk about how the astronauts are coming, how this actually re-entry is happening, a lot of technologies are there, which takes one full session actually. The International Space Station returnees, they are giving lectures or training lectures to the people who are going to become future astronauts. So some of the lectures will be available, and one can read those things or see the video separately. Now I will go to the next slide. These are the temperature aspects. See, space temperatures, space suits people are using when you go out for EVA, extravehicular activity, extravehicular EVA, because to repair or to put recently the space solar panels on the International Space Station, they are gone out. So when the astronauts are working outside the International Space Station, then their spacesuit will experience one side light, another side shadow. The one side light portion, it will be plus 250 degrees. On the other side, it will be minus 150 degrees centigrade. And all this will be in the spacesuit. The coolants will be running with the motors, and that is balancing in such a way that our body temperature will always be remaining comfortable. So if you see the principle, the temperature, what is observed, what is measured in the universe is minus, that is 2.7 degrees Kelvin. 0 degree Kelvin is the absolute zero. 2.7 K is the lowest temperature that is measured. Absolute highest temperature, theoretical temperature is 10 to the power of 32 Kelvin. Whereas highest known temperature or measured temperature or something like that, so it is the background, microwave background temperature, radiation temperature, that is 1 into 10 to the power of 27 only. So there is an order of difference of 5, which is not been observed. So these are, here we are hovering up to 400 kilometers somewhere here, and here is the temperatures. We can see these colors will indicate what are the temperatures and all. One can see these things here. We have given up to 10,000 kilometers, but it will go further up. 36,000 kilometers to the moon, 4 lakh kilometers we have to write. But it will be more or less in the space above this 600 kilometers, it will be asymptotic. Now, I want to talk to you about the International Space Station. There are people aspiring, I want to be an astronaut. So you can see Bandla Sirisha, who has recently gone in the Virgin Galactic. She wanted to become an astronaut, and very nice, very nice. She has been successful in going in the up to 86, above 80 kilometers height, like that. So here is our International Space Station. The what we call solar panels are removed, and we are only showing this one end progress. This is a Russian compartment. This is service module. This is also Russian. The initial things are this. And then FGB, where they store most of the material cargo. They are sending cargo satellites, and the material is stored here. Their food, all clothing, all that will be here. And you can see here node 1, that is called Unity. The node 2 Harmony, node 2 is Harmony is the end of it. So that is American part built thing. And then Tranquility, I think it is European thing. Node 3. Node 3 is this, and node 3 is used mostly for these exercise activities by the astronauts. There will be 6 people usually living in the thing, but now, right now, I think there are 7 people in the astronauts or cosmonauts total in this. International Space Station, in the International Space Station. So you can see here some of the things. This is the sleeping compartment. This is, I think, toilet. This exercise. This is where they can sit together, and it's like a meeting room, meeting hall, and this is a position where you will be, your things will get docking compartment. And here you can see this is Destiny bottom. You will find this cupola. Cupola is the thing which is facing downwards to see the earth. So most of the time, when they were taking photographs, they are taking from through these windows. And here is the JAM Japanese module, Japanese lab. So you can have an understanding of the station even without going into the full details. You can have technical data in the literature in the NASA's website, but not immediately done. But you have to go and search for it. Okay, next. This is how they live. Sunita Williams, you can see here the photograph. She is doing some, I think, maintenance work for this. He is a barber type of thing. They are doing their own hair cutting. 6 months they stay. So all the normal things they do themselves. So here, this is a meeting hall. I told once in a while, very rarely they meet. So say they on a happy New Year day, they will be having 16 times. They will go around 90 minutes one round. So suppose each one is from different country. He will celebrate my country's time, like that. So like that, they will be meeting. And here is the one. Actually, you see, this is facing towards the earth because they are not having this a massless or weightless environment. For astronaut living in the ISS, they don't feel which is up, which is down. But this cupola, they will make it in such a way that it will be facing the earth. That earth facing cupola side is bottom, and the remaining is up. Here you will find this circle. This is the just now I have already told when they come docking. See, earlier this is the way they were docking. About 4 years back, when I was observing this is the Canada arm, the robotic arm through to which is catching this incoming astronauts, carrying astronauts or incoming cargo or anything. So then it will be docking through the by the use of computer inside the International Space Station. You seeing through the cupola under. But nowadays, the SpaceX has come out with autonomous docking, laser-based docking. So it is interesting. That is the technology is really super. It has eased the troubles of the astronauts inside to a great extent, and it is very precise and absolutely problem-free. Here is a person whom I am referring to as cosmonaut. He is Russian cosmonaut. Center person in the photo is Russian cosmonaut. His name is Shalizhan Sharipov. He was there in Expedition 10, 6 months on the International Space Station. So during his 190 days mission on ISS, International Space Station, he has observed around Earth around 3,000 times. He revolved around there 3,000 times. When I met him at the conference at RCA, 2019 February, he actually because he has been expressing how he was feeling there and all that. Then one message he has told As we see from the space, no boundaries found between the countries. And he says all the human beings should be united without any boundaries among ourselves. That means no, we are all one. We are all on this planet Earth. Only one planet, one Earth. So we are all one, united. Space unites the world. The first thing what I have put in the slide, space unites the world. So that was the most important thing for all the human beings. In fact, all the border disputes, everything can be solved technologically, I believe, because everyday imagery is possible using these small satellites. I will talk about that in the other slide. So that will, so all nations, if they see their boundaries which are being observed or photographed every day, then they will see, oh, what I am doing is people are laughing at it. All the world is laughing at us. So let us not go to that extreme, and we mutually resolve our disputes. Like that, one can go about it. So next slide. These are the small satellites. These are the small satellites. 104 Dove satellites launched by the SHAR on February 15th, 2018. Dove satellites belongs to which company? Planet Lab. Who is the CEO of Planet Labs? Shankaran Sivaprakashan. So the Planet Labs itself belongs to Google. Google CEO is again Sundar Pichai. So directly or indirectly, these everyday observations is being done. Everyday imagery is done by more or less the people behind it are Indians. I am very proud of it. Okay, now let us see. The companies are American companies, world companies. Here you see the pink or yellow colored things at 11 o'clock. This is actually one set of satellites, not many. These are all one set of satellites. Here it is yellow color, which is at 11 o'clock. At 10 o'clock, sorry. Now 10 o'clock, this is this position. Now green color will come. That means the whole thing yellow has position is now it is in green position, like that. So you will be able to see the same constellation will be orbit will be tilted from one end to the other end and go on taking the images. Okay. Here. And what the small satellites, what the another thing is there important thing is high speed internet access across the globe. You know, SpaceX, they have put Starlink satellites and it will deliver high speed broadband internet to locations where access has been unreliable or expensive or completely unavailable. So SpaceX is doing the Starlink thing, and the Google's Planet, SkySat and Dove satellites constellation will give high resolution imagery daily. So this will solve a lot of boundary problems, I believe, if they put it into use. So United Nations may opt for these type of images to settle the disputes in the among the nations, among the participating nations, we can say. Please remind me how much 5 minutes before. Okay. This is our ISRO's one of the achievements. See, this lunar orbiter, I mean Chandrayaan-2 mission. When we have started on that mission, it was going around this. So this is called EPO, injection into the Earth parking orbit. You remember, you try to understand this. Here the distance is 170 kilometers, which is very nearer, less than even 200 kilometers. At this height, the speed is tremendous. But if the distance increases on this other side, it is increasing, it is 40,400 kilometers. This one is the distance between this point to this point is 40,400 kilometers. So it is what we call a Molniya type orbit. Molniya type orbit. See, for communication satellites, Russia uses this type of Molniya type orbits. So that here it will spend, because they are tremendously fast, it will only spend 1 hour here, it will spend 10 hours here. So the signals for the Russian communication satellites, they are getting signals from their satellites for 10 hours, whereas it is in the northern hemisphere after above, far away towards the North Pole side. So this type of orbits, if you go on increasing, this we called, this is the away, the anti-helion, ephelion distances will go on increasing. So you make it up to this point. When the satellite comes to this place, give a little bit propulsion, the engine should push it so that tangentially, then it will go like this. And if you give, when it reaches this, again you give a push, then it will go like this. Finally, when it reaches around 3,000 kilometers, 3 lakh kilometers and plus, then it reaches the lunar transfer object trajectory. Now it will be smoothly, instead of coming this side, it will be attracted towards this, and it will be going around the moon. That is how it. And we are about to usually lunar orbiting the gateway will be at a altitude of 100 kilometers only from the surface of the moon. So you can see here, this is the one what we have sent. This is the orbiter, the yellow one. This is the lunar lander. This will be running, say, from 2019, 7 years from 2019 up to 2026. So it is orbiting the moon, and we are getting the results. Life is 7 years. So this is working perfectly. Now what happened was, we got a little bit trouble when we are landing this portion, that is our lunar lander. It is supposed to be working for 15 days when the sunlight falls on these solar arrays. And after 15 days, these things will go into the dark, and it will never be able to recover again, because once it is cut off, solar power is cut off, even after some time, when it falls, or it is falling on this, it may be totally dead. So that yet when it is around 1 kilometer from the surface of the moon, it has not been able, it has crashed onto the moon. That is what has happened. Anyhow, we have been able to get the data. Our people will always be getting the data from this, and we will be able to know about it through the website, ISRO website. So another aspect which is really about the velocities of the satellite. This Parker Solar Probe has been going around the sun in a Molniya type orbit. This distance is about 61.6 lakhs kilometers between the surface corona and to this one. And it is going at a speed of space 6,90,000 kilometers per hour speed. That is a very tremendous speed. And fifth close flyby at the perigee of the orbit around the sun was on June 7th, 2020. We will see that how the orbiting thing is happening. Next slide. Here is the sun. This is our Mercury. This is the orbit of Venus. This is the orbit, blue one is the orbit of Earth. Now you can see here, see it started from here, 1 round, 2 rounds, 3 rounds, 4 rounds, 5th round. At 5th round, we are now at the 5th round. So this is about 66 lakh kilometers. So you can see here 2024, 2025, 2025, up to that they have planned it. 2018 started, 2019, 2020, 2021, right now 2022 and 2023, 24, 2025. So up to that it is planned. You can see here, now watch. Here you see 160 kilometers is the maximum speed, kilometers per second, this satellite will fly. This satellite, speed of the satellite will go to, here you see 100 coming sometime. So you will be able to understand there is no satellite which has flown at that speed so far. This is the only satellite experimental thing they have planned such a height, such a speed it is that speed will be here. Maximum speed will be at this place. See here, only short time. Third point is not there. First 169. So that will be when it is reaching this point. Now we will be, as an academician, I have been telling, I am interested to talk about my academic connections with the Nobel laureate, my professor's academic connections. He is my professor, Professor Anil Biswas, and he worked with the double Nobel laureate, Professor Linus Pauling, in California Institute of Technology, his postdoctoral work. Then after working with him, I went to Trinity College, Dublin. Here in Trinity College, Dublin, you will see, I was working in Trinity College, Dublin, is Professor E.T.S. Walton. He is the Trinity College, Dublin professor in 1980 period. He died in around 1995. This is
Professor?
Hello, sir.
Yeah,
Hello.
I'm sorry for interrupting. We are beyond time.
Okay.
Can you wrap it up? Thank you. Sure, no problem. Thank you.
One minute. So Professor Rutherford, atom structure, nucleus, everything we know. So it is he died in 1937 due to hernia problem. He is John D. Cockcroft. Both of them got Nobel Prize, and he worked for Manhattan atom bomb projects. So I have some academic connections. I just wanted to close this. Okay, I will be. This is when I worked in Japan. Again, another gentleman who is a veteran. I wanted to tell, but anyhow, due to time pass, I am closing it now. Thank you so much. I don't know how much I am able to make you sense, but I have been very fortunate to have this conference as a keynote speaker. I am able to do my as a senior citizen what I can provide to the students. Thank you so much. Thank you all.
Our pleasure, Professor, and thank you so much for that lecture or speech. Next, it's our immense pleasure to welcome the Professor of Civil Geotechnical Engineering, University of Baghdad, President of Iraqi Geotechnic Society, Iraq. He is a BSc, MSc, PhD, MISSMGE, Professor of Civil Geotechnical Engineering, University